Kia ora Year 11 and 12. This is the first video in a series of videos I'm going to do that are aimed at my 12 MAA class, but might also be useful revision for my A-level class or for students doing Cambridge AS. So in this video I'm going to look at how to solve quadratic equations that don't look at first like they're quadratics. So I'm going to go through the following examples. I recommend that you pause the video and have a crack at all of them yourself. So these are the first couple. Those two are fairly level one-ish, just as a bit of a warm-up. And then we're going to look at these equations. So that one, which is a quartic, then this one, which has got x to the power of 6 in it, and lastly this one, which has got a yucky looking square root thing in it. So just screenshot those or have a look and try and do the problems yourselves first, and then go back and go through whatever you need to. Alright, so going back to the first two questions here, these can both quite easily be popped into our happy quadratic pattern. So let's take a look at this first one. All we have to do to get it in the usual pattern with descending powers is this: x squared, and I'm going to subtract 4x from both sides, plus 3 equals 0. And that's how you need any quadratic equation. To solve it with whatever method, we have to have the right hand side equaling 0, with a few exceptions, but that's our basic method from way back in year 9 or 10. Now this one's pretty easy to factorise now. I did that on purpose, so here we go. We've got x here and x here. We notice that this is a plus and this is a minus, so my sign pattern must be minus minus, and it's going to be x minus 3 and x minus 1. So that's the factorising done, but not the solving. We've got two things that can make this whole thing equal 0. Either this is 0 or this is 0. So we have x equals 3 or x equals 1. So that's the warm-up. That's definitely not a merit or even definitely not an excellence question. That's an achieve level 2 question, but it leads nicely into some harder ones. So our second question here doesn't look like a quadratic. But it is a quadratic if we multiply everything through by x. So let's see what I mean. Well, we've got x plus 3 over x is equal to 4. Remember, as long as I do the same things to both sides of the equation, I can't go wrong. So we're going to multiply everything through by x. X squared plus, well, let's see what happens here. We've got 3 over x times x is equal to 4x. Now you won't usually have to write that line in, but that's doing it very slowly to start with. So that gives me x squared plus 3 is equal to 4x, and we're back at a similar place to that first question. So we get x squared minus 4x plus 3 equals 0, and we can factorise, and what do you know, it's exactly the same equation as the first one. I did that on purpose. So x equals 3 or x equals 1. Right, so that's the first big idea in here, that if we start with something like this, by a little bit of manipulation, we can force it to be a quadratic, and that's a really good thing because we know how to solve those. So let's see how we can apply that to the next three examples. Now these look hard, but once you get the hang of them, they are super easy. The clue that this might be a quadratic is that we've got three terms. We've got a constant on the end, and we've got an x to the power of 4, where we'd like to have an x squared, and here we've got an x squared, where we'd like to just have an x. So we can think about this as follows. Let's change x over to a different variable. And let's say we're going to call that u. So we're going to make a quadratic in u. So let u equal x squared, and then we'll just see what happens. Now you're not going to write these steps out very often, but this is what it's all about. What is x to the power of 4? Well, x to the power of 4 is just x squared squared, which is u squared. So we can rewrite this equation as u squared minus 4u plus 3 equals 0. And again, we're back to a really easy quadratic. So the first thing we do is we factorize like this, and that gives me u equals 3 or u equals 1. But remember, we're not interested in u except as a stepping stone. We want to find x. So now we have to say, hang on, u is equal to x squared. So x squared is 3 or x squared equals 1. That means that x is equal to either the square root of 3 or the negative of the square root of 3. And x is either equal to 1 or negative 1. So don't forget there are two solutions to that little equation and two solutions to that one. So going over it again, once you recognize that the pattern you've got here with something to the power of 4 and something to the power of 2 can be transformed into a quadratic, you do that by making a substitution. And it's quite common to use u equals, but you can use whatever you want. So we solve the equation in the other variable, in u. Right, so we've got this equation with u in it, which is easy. So we do our quadratic stuff on that, and then we remember that we actually want the answers for x. So that's the last step. Now the next two questions follow this pattern exactly. Here's the next one. We've got x to the power of 6 and x to the power of 3. So this time we're going to say let u equal x cubed. So what's u squared? Well, u squared, and this is the whole reason we picked it, is x to the power of 6. So we can rewrite that quadratic as u squared minus 9u plus 8 equals 0. Factorising, so it's suddenly turned into an easy quadratic. We've got u minus 8 and u minus 1. That gives me u equals 8 or u equals 1, but we want x, not u. U is just the same as x cubed. So here we're going to get x is equal to 2 and x is equal to 1. Now some of you who are taking AS and maybe revising this for A level might be thinking, depending on when in the year you watch this, hang on, I thought, so block your ears to the next bit if it's going to confuse you, but just in case, I thought that there were meant to be 6 solutions to that equation because the highest power is 6. And that's a thing called the fundamental theorem of algebra, and you learn about that either when you get to level 3 calculus or Cambridge A level. And you'd be right, there are 6 solutions. So what I really should have written here, instead of just solve, is find the real solutions. Right? If you're watching this video from my 12 MAA class, I don't want you worrying about this at all. The answer, as far as you're concerned for now, is x equals 2 or x equals 1. But if you're watching this and you're in my A-level class, and it's past term 1, you'll recognise that there are also some complex solutions to those equations. But I'm not going to touch on that in this video, except to say that they do exist. But the only 2 real solutions are this one and this one. And then there are 4 other ones that you probably are going to think of as quite weird. Right? So that's that one done. Now the next one looks hideous, but it's the same pattern. It's got a square root thing in it. So solve this, and the thing that's making you think it's a quadratic is that it's got these 3 terms, a constant at the end. This might turn into somehow some kind of x squared thing, and this might somehow turn into some kind of x thing. So pause the video and see if you can work out what substitution you're going to do. Right, so we're going to let u equal the square root of x. Okay, so I'm looking at that term there. What's u squared? Well, u squared is just x. So that gives me u squared minus 3u minus 10 equals 0. Factorising that one, gives me u here and u here. I'm going to do a plus and a minus, and I want minus 5 here and plus 2 here. As usual, we now solve for u. So u equals negative 2 or u equals 5. But u is equal to the square root of x. So let's think, are there any numbers for which, any values of x for which this thing is true? No, there aren't. By definition, the square root of x has to be a positive number, so this one's going to give me no solutions. This one here, though, is going to give me the following solution. If I square both sides, x is equal to 25. Alright, so check these ones always. They're a bit easy to muck up. The square root of 25 is 5. Let's go right back to the start and check that x equals 25 as a solution. Alright, so substituting in here, we get 25 minus 3 root 25 minus 10, which is 25 minus 15 minus 10, which does indeed give me 0. So we're happy that we've found the only solution to that one, which is that x is equal to 25. So there you go. They pop up quite often in level 2 papers. If you're really lucky, they can be excellence questions, and they come up in AS lots. But this pattern comes up all through maths from this stage on. So quadratic equations are everywhere, but they don't always look obvious when you first see them. Thanks for watching. Please email me with any feedback about whether this helped, and if it did, I'll keep on going.